Alright guys, in this video we're going to be looking at some VSEPR and hybridization questions. So right here we've got three diagrams, Lewis structures for ALCL3, and they tell us that it has a trigonal planar geometry. Which diagram, 1, 2, or 3, can be eliminated based on geometry? Justify your choice based on VSEPR's theory. So trigonal planar, the most important thing, has three electron domains, or three areas where we have bonding occurring, or lone pairs. So diagram 1 does have that. We've got a domain here, here, and here. So that's trigonal planar. Here in diagram 2, though, we've got an electron domain here, 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 and here. So that actually is a tetrahedral shape. So that can't be trigonal planar. And this one also has 1, 2, 3 domains, so it's good. So for this question, diagram 2 does not have trigonal planar geometry. Have trigonal planar geometry. I'm going to shorten that, blah, blah, blah. Okay, justify your answer choice with VSEPR theory. I could say because it, diagram 2 has 4 electron domains, making it tetrahedral in shape. Okay, so it does not follow. That would be your justification along those lines to determine that it is not the correct diagram. So this question, a Lewis diagram for C2H4 shown above. In the actual C2H4 molecule, the HCH bond angles are closest to what? Okay, so if we have to know the shape, okay, remember if it's tetrahedral in shape, it's 109.5. For tetrahedral, it's 120 for trigonal planar, and it's 180 for linear. These are the main ones that you'll need to know. In this case, they're making it look like the HCH bond is like 90 degrees. But they are trying to trick you. That is not the right angle. Instead, we have to look here. Okay, what kind of shape is this carbon forming right here? It has 1, 2, 3 domains. So this is a trigonal planar shape, which means we have 120-degree angles. Okay, and this one doesn't ask for y's. It just wants to know what bond angles are closest to. So I'll just say 120 degrees. All right, those are our VSEPR questions. And now we're going to look at a hybridization question. When reaction 3 occurs, does the hybridization of the carbon atoms change? So here's reaction 3, and we're going from a C2H2 to a C2H2Cl2. Okay, C2H2 is going to look something like this. And it's linear in shape. Okay, and C2H2Cl2 is going to look something like this. Okay, and it is no longer linear. It is now trigonal planar. So right here we have it in linear shape on our carbons. We have 2 domains. And on this carbon, we've got 3 domains. And we will have a trigonal planar shape. So we're going from linear to trigonal planar. So we're going from SP to SP2. So yes, it does change, and A would be the correct answer. If you're having struggles figuring out, well, I don't know what shape this would take, okay, It's just going to take some practice and some getting used to seeing how it will play out. Okay, it carbons will bond on the carbons and then will match on each side, the bonds on each side like that. We're not going to double up and leave the carbon by itself. Okay, so it's just going to take some practice recognizing how molecules work. Okay, this is an example of like C2H4. C2H2 is going to look like this. C2H6 would look like this. And it's just going to take practice recognizing these molecules and how they would form just like that.